I'm going to record the OneNote as I write down everything. So we can go look at it. Yeah, you can look at it later on. But sometimes it doesn't really work. Okay. It seems to work right now. We'll just go off with it. What? I didn't hear you. So let's do number 1 or number 6. All right, guys, calm down. Let's get started. So 6 is f of x equal to square root of x squared plus 4 all over 2x plus 1. So what do? We're trying to find f prime of x. Just by looking at it, what do you think we should do?
Quotient rule.
The quotient rule. What is the quotient rule?
F of x times g prime of x minus f prime of x times g of x all over b squared.
Okay, so in other ways, low d high minus high d low over low squared. That way is technically correct, but you do need to state f of x over g of x, because you don't know which one's on top or bottom. So what do we have on top? So what do I take the derivative of first? So what is the derivative of, well, we can rewrite the low. So what do I write right now? You guys? Now what power is that? Negative 1/2 times 2x. Now we minus, and we do the opposite of that, which is x squared plus 4 times 2. All right? So on the test, you will need to do this, but you guys will probably have a problem where you'll need to prove it. So make sure you guys go over the objectives with it. And in the bottom, we have 2x plus 1 squared. This is equal to, so we can actually just rewrite it. We have these cancel out. We have x times 2x plus 1. Can we quiet down a bit, guys? We have x squared plus 4 and the square root of that in the denominator minus 2 times square root of x squared plus 4. And since we want common denominators, we can just multiply right here by the square root of x squared plus 4. And all of that is still over 2x plus 1 squared. Okay? So this is x times 2x plus 1 minus 2 times x squared plus 4 all over square root of x squared plus 4 times 2x plus 1 squared. Everyone clear on that? Do you guys understand how we actually took the derivative of, say, 2x plus 1 and the chain rule that we used for the next one? Or do you need me to go over that? So do you guys want me to go over the chain rule?
Sure.
Okay. So the chain rule, so just by looking at square root of, we'll just do x squared plus 4 to the 1/2. All right? The chain rule is a bigger version of the power rule. The power rule is n x to the n minus 1. The chain rule is taking this and then doing dx right there. Okay? Now in a power rule, this doesn't exist because the derivative of x is 1. But in the chain rule, we show dx because x in the chain rule is actually a separate expression. So this would be 1/2 by bringing the exponent down. We rewrite what's in the parentheses. 1/2 minus 1 times the derivative of what's inside. Okay? So we have 1/2 times x squared plus 4 to the minus 1/2 times 2x. You guys get that? Anyone still struggling with this part? No? Okay, I didn't hear anything, so we'll just move on. Okay. For this, we can just simplify the numerator now, which is, this goes 2x squared plus x minus 2x squared minus 8. So we have x minus 8 all over square root of x squared plus 4 times 2x plus 1 squared. Yeah, make sure you guys keep on passing the sign-in sheet, so whoever hasn't signed in, signs. So we're done with this problem. Are we good with it? Okay. Now 7 is with implied differentiation. And that just means we don't have a function where y is equal to something. Y is in it. All right? So what's the derivative of 2 or x squared? 2x. What's the derivative of 4y squared? Now this was again something like the chain rule, where this is a formula that, they use u, but I'm just using x. So imagine this was y. We brought the 2 down. 2 times 4 is 8 times y times dy over dx, which is y prime. What's the derivative of 5? Because it's a constant. We have therefore all right, so I just isolated the y prime. Are we good with this? They can get very long, as you guys have seen with the homework. So now, we're still supposed to find y double prime. Okay, so what do we use to find y double prime? What rule do we use? The quotient rule. So we have low d high, which is -1, minus high, which is -x, d low, which is 4 times what? 4 times y prime. All right? And all of that is over low squared, which is 16. But right now we'll just leave it like this. 4y squared. This is equal to minus 4y plus 4xy prime all over 16y squared. This is equal to, we can take out the y, we get minus 4 minus y plus xy prime all over 4y squared. Are we done at this point? Nope, because we still have y prime there. But luckily, we already found that. So this is equal to minus y plus x times, we subbed in for y prime, all over 4y squared. Let's see if this was even working. Seems to be working. Okay. So what do we now? What do we do now? We can do something. Yeah, the common denominator, which is what? On the top, it's 4y, but we need to multiply by 1, so we do that. This is equal to minus 4y squared minus x squared all over 16y cubed. All right? And at the top, we can just take out the negative sign. We have x squared plus 4y squared all over 16y cubed. Now, why is this awesome? Because this was our original problem. So this is equal to minus 5 over 16y cubed. All right. Differential equations, which is what you guys will take in 1 year, is all about doing that. Or it's all about isolating y from equations. So do you guys have any questions? No? It's just, you guys need to understand how to take a derivative, and then it's basic algebra. So moving on to 8. That is. All right. So we again have to find y prime. Okay. So what do we do first? We take the derivative of both sides. So we bring down the exponent. We have 2 times x squared plus y squared. Now the derivative of this inside can be a bit tricky, but it's not that bad. That's 2x plus 2y times y prime. All right? The reason we have a y prime is because we're differentiating with dx, because it's the derivative of something with respect to dx. Otherwise, if it was with y, the derivative of y would be 1, and the derivative of x would be x prime. Did that make sense? So all of this is equal to the derivative of the right side. What rule do we use now? The product rule. So we can do x cubed times 3y squared times y prime plus 3x squared times y cubed. Okay? So what do we do now on the left-hand side? What's the word? We distribute these two terms. So we have 4x times x squared plus y squared plus 4y times x squared plus y squared times y prime. Do you guys see how that happened? We have a 2x here. We multiply and then we have a 2y times y prime. We multiply that with everything and this with everything. All right. So once you guys know that you needed to do that, then it's again basic algebra in isolating y prime. So on the right hand side, we have 3x cubed times y squared y prime plus 3x squared y cubed. On this side, we have 4 we have 4y times x squared plus y squared minus 3x cubed y squared. All of that is being multiplied by y prime. On the right hand side, we have 3x squared y cubed minus 4x times x squared plus y squared. Right? We brought this over to this side, and we brought this over to that side. Therefore, y prime is equal to we can take out an x from everything. So on the top, everything had an x in common, so we just took that out. And on the left, they had a y in common. So now it's a bit more simplified. Yeah.
You guys use the swap in 2, 3, and did that.
In what?
In differential equations, you guys use in
We do way more different problems that don't require these sort of basic rules. Yeah, okay. There may be one more way to do this problem actually. Like for this problem right here, I think there is one more way to do it. They want you to do it this way, but you can do it one more way. You'll get the same answer, so it may not be easier. Oh wait, no you can't, never mind. Because the y cubed is on the right side, so I thought you could just isolate it, but there's y squared on that other side as well. So it would be even more messier. Okay, never mind, but okay. Are we good with this problem?
Yes.
Okay. So now we're actually going to prove a rule. So on this exam, they only want us to prove the product rule, but I can go over the other proofs as well at the end. All right, so they give us f of x is equal to u of x times v of x. All right. So just f of x plus h is x plus h plugged in wherever there is a x. So what is the definition of a derivative?
X plus h minus x plus h.
Is this right? You need the limit. Okay. So it's the limit as h approaches 0. We know what f of x is. It's u of x plus h, v of x plus h. Then we subtract u of x, v of x, all over h. Okay? Now, the way they prove it is they do some math magic here. Yep. It's basically something that mathematicians can do, and neither, like, we're not clever enough to actually figure it out. Or I'm not. Okay. So they add u of x plus h, v of x, minus u of x plus h, v of x. I would never have known to do that. So this is the actual proof that they show in your dyno notes. The reason we can do that is because we're adding and subtracting the same thing, so it equals out to 0. So we didn't change the original expression. So then this is equal to the limit as h approaches 0. They forgot something. They have u of x plus h times v of x plus h minus v of x all over h plus the limit as h approaches 0 of v of x times u of x plus h minus u of x all over h. Okay, so this is how it worked out. They redistributed the stuff around. So we have a u of x that is being multiplied to a v of x plus h and a minus v of x. Okay? So we can take the u of x plus h out and just have these two terms. Okay? They took that out of those spots, and everything's still over h. All right? So they had a u of x plus h at two places. One was being multiplied to v of x plus h, the other v of x. So they brought that down, and we have v of x plus h minus v of x still over h. And what does that tell us? What does this look like? The derivative of v prime of x. And this just goes to u of x, since x is approaching 0. Okay? Any questions on that? Okay.
What about the other side?
Now the other side, a v of x is multiplied to a u of x plus h. So we have a u of x plus h here, and a v of x is being multiplied to a minus u of x. So we have a minus u of x here. All over h. Do you guys see how that happened? No? Okay, let me go over that again. So the whole idea is to isolate something that looks like the definition of a limit, okay? We have a u of x here and a u of x here, okay? We took that out right there and put it there. Both of them are multiplied to a v of x and a minus v of x, which we have there, okay? And since all of that is over h, that's the definition of v prime of x. So we can sub that in, sort of. And then on the right-hand side, we have a v of x. Now in the original function, we have a v of x being multiplied to a u of x plus h and a minus u of x, which we can bring down here, okay? And then we again see the definition of a derivative. So this stays as v of x. This goes to u prime of x. Okay? So therefore, it's u of x, v prime of x, plus v of x, u prime of x. Someone told me that Dr. Tyler is gonna have you guys prove the quotient rule. I don't know if that is true, but if he is, it's a bit more tougher than this. So make sure you guys go over it in your dyno notes, and make sure you guys also know the proof for the power rule, because that could be on the exam as well. Yeah. I'll go through both of them after we finish the exam. All right? So are we good with this? Who said no? Did someone say no? Okay. On to 10. F of x is equal to x squared plus 1. Can you quiet down, guys? Times 2x plus 1 cubed. Okay? Yes?
Question on the last one. If he makes us do the power rule, is he going to give us the x plus b to the n? Is he going to give us all that string of numbers, or are we just going to get that memorized?
You will need to have it memorized and just write it all down. And the only thing that you can do is just memorize it. I mean, you can understand there's little patterns there that help you go from step to step, but most of it is just memorization. He did that to us on the second exam. He gave us the power rule. The first time, I think it was the product rule. The second time, it was the power rule. So that can happen to you guys as well. For this one, it's just using derivative rules, but in a bit more complicated situation. Okay? So what's the first thing that we do? What?
First under the second.
Okay. X squared plus 1 to the 1/4 times the derivative of the second is 3 times 2x plus 1 squared times what? 2. Plus the derivative of the first, or we can just rewrite the second here, times 1/4 x squared plus 1. What do we have as the exponent? Negative 3/4 times 2x. All over, we don't have that in here. Okay? So this one incorporated the chain rule and the product rule. And then there's many other combinations that they can put on. They can even have negative exponents and stuff. So if I have here x to the negative 3, right? They will show it like that. Okay, if they ask you guys to take the derivative of that, make sure you rewrite it as x to the -3. Okay, it's just a bit easier to see what happens. Then this would be -3 x to the -2, or sorry, -4, which is -3 over x to the 4th. So that's just a side note. Make sure you guys know how everything can be manipulated. Any questions on that? Yeah.
If you just say that it's pattern, if we do it, that, does it need to be in the denominator? Or can we write it negative?
I think both are acceptable. I'm pretty sure they won't take points up for that. They won't give you something as simple as that though. It'll be part of a bigger problem. All right, back to this problem. So now here is what we did the very first unit. We learned how to simplify this. You guys remember?
We sure do.
Yeah. Okay. I'm just gonna go with it. So this sort of goes to 6 times 2x plus 1 squared times x squared plus 1 to the 1/4. And then we have plus 2x plus 1 cubed and x on this side all over 4 to the x squared plus 1 to the 3/4. All right? We multiply this, what 2x? This should be a 2 here. Yeah. All right? So right now I haven't done any manipulation, it's just simplifying. The common denominator is 2 times x squared plus 1 to the 3/4 all over 2 times x squared plus 1 to the 3/4. All right. So then on the left we have 6 times 2x plus 1 squared times x squared plus 1. Okay. I think yeah. Which part? Yeah, it should be. All right. We can take out what they have in common, which is 2x plus 1 squared all over 2 times x squared plus 1 to the 3/4. And the remaining we have 12 times x squared plus 1 plus x times 2x plus 1. This is 12x squared plus 12 plus 2x squared plus x. So here we have 2x plus 1 squared times 14x squared plus x plus 12 all over 2 times x squared plus 1 to the 3/4.
Can you go up a little bit?
Yeah. Is this good? Make sure you guys know how to do that.
You like to math, so
Yep. Any questions on this, guys? No? Are you guys still trying to figure it out? Okay. It looks good. I don't know if there's. No? No, I just.
Like, does that mean you can all, like, condense yourself together?
What?
What if we all refuse to take the test? We're going to choose silence.
Oh, that's nice. We saw this last time, right? Yeah.
Oh, that's so true.
Okay. All right, let's get back to the remaining problems. Are we are good with that other problem, right? Okay. So the last one is d over dx of f of x, that quantity squared plus f of g of x. All right? So the idea with this is just to understand your basic knowledge of how derivatives work. So it's just working with directly sort of like variables or functions. And then they give you a whole bunch of values. Sometimes you might not even use all of these values. That's a 6, right? Yeah. Okay. So what do I do now?
You do 2 times
Yeah.
f of x.
2 times f of x times f prime of x. Okay? So if you guys want to think of it a different way, what is y always equal to? F of x, right?
Okay.
When you have an equation f of x equals to something, in other terms, that equation could be said y is equal to, right? So right there we have f of x squared. In your head, you can sort of think of it as y squared. So then we have 2 times y prime, or 2 times f of x times f prime of x. Okay? Yeah. So what do I get for the right side? Times what? G prime of x. Do you guys see how that happened? We took the derivative of the outside, which is f prime of whatever is on the inside, and the derivative of the inside. Okay? Make sure you guys understand this, because they might even have 2 or 3 problems like this. They could, yeah. So now it's just subbing stuff in. So we're gonna use x equal to 0 to solve all of this. So we have 2 times f of 0 times f prime of 0 plus f prime of g of 0 times g prime of 0. Okay? This is equal to 2 times -2, because we have that value up there. Prime of 0, or f prime of 0 is just a 1, plus f prime now of 2 times a -1. Okay? This is -4 plus f prime of 2 is 3 times -1, that's equal to a -7. Okay? Did we use g of 1 in there? No. Did we use g of 2 in there? No. Those are there because students will do it wrong and they'll have g of 1. So then they'll just think they're doing something right and use those values. So make sure you guys really understand this. Yeah.
But they will give us all variables we need.
Yeah.
We shouldn't have any, if we have anything left over, we definitely.
Yeah, if you have something left over, you definitely did something wrong.
What would be, like, if it was like f squared, g squared, x, like, how would you do that? Like,
Say that again?
so it's like the first part of x squared, it was f squared, g squared, x, like, I'm just trying to understand.
So if we had that, and then we have g of x squared.
Well, f of u, yeah, kind of, f of u, x.
Oh, so let's just say we had that. Okay? Let's say we had all of this. What would that give us? So always remember, derivative of the outside, and then you keep on going inside. So here we have like 3 layers. So the derivative of the outside is g prime of f of x, that quantity squared. Okay? Times the derivative of the inside is 2, which times f of x. Okay? Times now f prime of x. Okay? They could they could have that on the test. And you guys would need to understand how that worked. Okay? We had the derivative of g of x with everything on the inside times the derivative of what's the inside, which is 2 times f of x, and then we still have f of x, which was inside, so that's f prime of x. Okay? So that's the exam, but I can go over the proofs now, that like the quotient rule with you guys right now. Any questions on this right now? No? You guys understand how to mess around with that. And then they could easily have had times the product rule here with, again, yeah, g of x. So then you need to do the product rule because those two are not the same things. Okay? Like for that, it'd be the derivative of the first times second plus the derivative of the second times first. Okay? Yeah.
Shouldn't you have g prime of another bracket all around that f squared? Because right now it's the same thing.
If you want to, yeah, that's fine. Yeah, you may actually need the bracket.
Wouldn't that be the same thing that g prime of f squared?
No. So are we good with this? Okay, so now I'm just gonna open up my Dino stuff for you guys. We're on unit 5, right? if you like, you guys will find out if your laptop gets broken or anything, you're like dead for a good few weeks. I don't know. Everyone always saves everything on that one laptop. Like, I don't have any external hard drive, although I should buy one. Okay? Yeah. So they're cheap, but I don't know. I just have not had the motivation to do it.
You don't believe in Murphy's Law, right?
In Interstellar, they did a good twist on that.
Can we just say the greatest movie ever made?
Yes.
I love you.
Okay. So, okay, this is proving the quotient rule here. Okay? So right now, this is just what the quotient rule is. Okay? It's, you guys know it, low D high minus high D low over low squared. So now, in order to prove it, we need to use the definition of a limit. Okay, I'm just gonna work with right here, whatever I wrote. So we have u of so originally it was u of x over v of x, right? So then we just sub in u of x plus h over v of x plus h minus f of x, which is u of x over v of x, okay? All over h. That's the definition of a derivative right there. In order to simplify it, we need to multiply by a common denominator, okay? So the common denominator is v of x plus h times v of x, okay? I don't think I'm pretty sure the online version of this, they're not going to be able to see this, but. So we multiply by the top and the bottom right there. Okay? Or, let me do this. All right? So if f of x is equal to u of x over v of x, this is just using the definition of a derivative. We replace x with x plus h, v with x plus h, f of x plus h minus f of x over h, right? The common denominator, v of x times v of x plus h, all over the same thing. The next part, so right now in this section, it's just simplifying that. It's not anything terrible. We have u of x plus h times v of x minus u of x times v of x plus h. You guys can all do that. The next part is again what they did with the product rule. This time they add u of x times v of x minus u of x times v of x. Okay? So this equals to 0, and they add that there. All right? Because math, that's it. You guys all should have this program in your computer. It's the snipping tool. I think it should already be downloaded or something. You can search it, and it's always very useful to put stuff in OneNote and just paste the strings. Okay, so now they do something crazy here. Okay, so they take out a v of x. In that original problem, there's a v of x being multiplied with a u of x plus h, and a v of x being multiplied with a minus u of x. Okay? They combine them to get the definition of a limit or a derivative. Okay? U of x plus h minus u of x, and they just bring the h's up into the numerator. Okay? You all good with that? In the original problem, we have a u of x multiplied with a v of x plus h and a v of x. Okay? So this is just looking at the signs. They subtracted, so that's why this becomes a positive. That's a positive there, and this sign here becomes a negative sign there. Okay? So now they just took out a u of x, which was multiplied to a v of x plus h and a v of x. All right? Any questions on that? So it's not that tough to see what's going on. Maybe it just takes a moment to sit down and look at what's happening so that it's, you guys can absorb it and then be ready for the exam. This whole thing is the definition of u prime. The second part is a definition of v prime. And since h is going to 0, at the denominator, this just goes to v of x, okay? So we have v of x times u prime of x minus u of x times v prime of x over v of x squared. All right? Do you guys want me to say that again? Or wait till you guys just take it in? Yeah. Yeah, we can do one of those. So yeah, everything on the objective can be on the test. Just because this exam didn't have anything with linear lines and finding the angle, that doesn't mean you won't have that on your test. Yeah, I'll go over the power rule after this. What? No, they can be on exam. That's what yeah. Just because they're not on this practice exam doesn't mean they won't be on your exam. Okay? All objectives are fair game. So we're done with this, right? Yes, okay. So let's go over the power rule, which is a bit more confusing. That's not there. Here it is. So with the power rule, it's memorizing what's going on, but then it's easier to memorize because there are little patterns that go along with it. Okay? So originally it's x, which is equal to x to the n, right? We use the definition of a derivative, x plus h to the nth power minus the original function, which is x to the n, all over h. Okay? We take out 1 over h because we don't want to write all of that over everything. Then it's just understanding how x plus h to the n can be simplified. Okay? The way it works is you just have to memorize it and see the pattern that goes on. So we have, that's the only way that I do it, or I'm not, I don't know any other better way to tell you guys. So we have x to the n. Then in the next term section, we have x to the n minus 1. And the next, we have x to the n minus 2. And it goes on. And that goes on until we reach x. Okay? Technically x to the 0. All right? In another part, we have, so this starts with the second term. We have n over 1. Okay? So we have n over 1. Then that goes to n times n minus 1 over 1 times 2. This follows like a factorial, where it's n minus 1 times n minus 2 over 1 times 2 times 3. And that goes on till we have, it goes back down again. So we have n times n minus 1 over 1 times 2, n over 1. Okay?
So basically, with those dot, on the right hand of that,
Yeah. So on your, when you guys will have to prove this, you won't need to write down everything. If you guys just go up to like the second, like the first 3 terms, like that far, and the last 3 terms here, you should be good. Yeah. Okay? So in simplifying x plus h to the nth power, if you go to the first 3 terms and the last 3 terms, I think that is good enough. They probably won't take off points for not writing everything, because you can, because, you know, wherever. Okay? The rule for the h's, it starts off with an h, it goes to h squared, dot, 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 until it reaches h to the nth power. All right? And those are the 4 parts. Okay? Those are the 3 parts of writing all of that. And then in the end, we still have minus x to the n. Yeah? On my exam, like, I actually didn't have it all memorized. I just wrote like x to the n's and h to the n's and whatever, put some dot, dot, dots in there and made it equal to x to n times x to the n minus 1. Like, that's, I lost points, but, you know, I didn't lose everything. So, all right. Once you have this huge term written, then it gets a bit easier. So x to the n, both of those cancel out. All right? Then we see that this term has only one h multiplied to it, while the rest of them have more than one. Okay? That means if we take out a h from everything, we have a term here, n to the x to the n minus 1, not multiplied by h, while everything else has an h. Okay? Since it's the limit as h approaches 0, everything else goes to 0, except the term that we got the h out of, which is n to the x, n times x to the n minus 1. And that's the answer. All right? So my recommendation is you guys understand the pattern that's with x's, with n's and h's, and just sort of memorize that. It uses Pascal's triangle, but I'm not going to go into how that works. Yeah.
Did we get 1 point if all we wrote was that very last part?
Probably not. If this is all you wrote, and this,
Yeah.
you might get 1 point.
Yeah.
Because you do write the limit with the h of that.
That's great.
But this will be like 7 points or something. On, yeah. All right. Are we good with this? If we're good with this, we can go on to that problem with the angle and the slope. All right? Yes. No. Let's do this one. So this is a problem that you guys did in class. Yeah. Oh. So originally they gave us y1 is equal to x squared, y2 is equal to x cubed, and they both pass the curve at the point 1, 1. All right? So we have to find the angle right here. Let me highlight that. We have to find the angle that they make right there. The angle that their tangent curves make. So the first step is to find the slope at that point. So m1 is equal to dy1 over x1, or dx, sorry, at the point P. That's equal to 2x at the point, which is equal to 2 times 1, which is equal to 2. Okay? So that's the slope of that tangent line.
We don't write the dy over dx at p, 2x at p, will they hit on the point?
If you don't write this,
Yes. They might.
I don't know. They shouldn't.
Or put 2x at 1 and then put 2 times 1.
If you put 2x with, I would write it. Or at the very least, write d of x squared. At the very least, write that. All right. So now, a slope tells us the rise over run. Okay. So this is rise over run. You could have a basic vector is made out of I and j components, right? So since the slope is 2, it's basically saying 1i plus 2j. Okay? This, if we had say a 3 here or something, this could be simplified to I plus 2/3 j, right? So that's why we always use the formula I plus m t j. Okay? Because we can always isolate it so that a coefficient is in front of j. Yeah.
This is where we have to put the plus or minus or something.
What do you mean plus or minus?
I don't know, it's some part that like plus or minus.
Maybe that's like depends on that example. It may depend on that example where you're like square rooting something or squaring a square root or something like that. So always remember this basic formula. Where did they do it?
There were plus or minus I plus 2j.
It's
And
good
I
to
don't
have a
understand
vector
why
in
they
the
did it,
direction on that.
but they did.
So I don't see a plus or minus on here though. What are you guys looking at? Okay. Let's just finish this and then we'll see. Okay. So then V1 is equal to I plus 2j. Okay? Finding the slope of the second dx at p is equal to 3x squared at p, which is equal to 3 times 1 squared, which is equal to 3. Okay? So then V2 is equal to I plus 3j. Do you guys all understand how that happened? Did you say no?
They said that.
So we're good with that? When we originally did this, the definition of a dot product was A dotted with B times the magnitude of both of them times cosine theta. All right? That's a very basic definition of a dot product. So we get cosine of theta is equal to V1 dotted with V2 all over the magnitude of V1 times the magnitude of V2. Okay? This is equal to 1 plus 6 all over square root of 5 square root of 10. That's 7 over square root of 50, which is 7 over 5 square root. It's the dot product. V1 dotted with V2 is equal to 1 times 1 plus 2 times 3. Yeah.
So are those vectors we found, are those called the tangent vectors?
Yeah.
So they were like find the tangent vector, that would be the equation.
Yeah.
If they were like find the normal vector, then we take the slope and use the reciprocal side.
Yeah.
And that's the tangent equation.
You can.
And then
Yeah.
what do you do? Is that the slope and then you plug it in y?
If you wanted just a vector, you just do v equal to I times m and j. But
The equation and y.
that's something else. That's then using that to find an equation of a line, and then you find that where they intersect. So that's like, that's a different problem. But what we did here is a tangent vector, and normal vector always points towards the center. So those would go that way. That's why we would do the reciprocal of it. Okay? So that's how we get cosine theta, and they're always fine with just leaving it, yeah, with cosine equal to cosine theta as the answer. Yeah.
And this was to find unit vectors? No,
This was just to find cosine theta.
so the y value, you already say the y value for finding it, it's just there.
Yeah. I mean, we take the derivative and then we use the point to, like, we need the y value to take the derivative.
I meant, they just said x equals 1 instead of 1.
Where?
You talking about the derivative?
Do you want me to look at a different problem?
No. They gave you the 0.11, but you're saying like, you only needed the x part.
Yeah. Do you have a?
Yeah, so, for vector scaling, is it like, A1 and B1 A2, the type of A1 and B1.
Are you asking about this part? The dot product? So the dot product is always the I components multiplied with the j components multiplied, and then you add them. I mean, that's something that you just have to memorize sort of and know that a dot product is that. And then we use the definition of a dot product to find cosine theta. It looks good. So make sure you guys study, and this will be online, and hopefully it all recorded correctly. And it will be online. All right, we're good, guys. Thanks for coming. And if you guys haven't signed yet, there's a sign-in sheet somewhere over there. Now. That was for last class, like last week. But we're trying this new thing where I'm trying to record what I write on OneNote. So then if it worked out correctly, it's going to be online. Yeah. Like the point is for commuters that can't come and that sort of a thing, those would work. Yep. Somewhere. Here you go. So hopefully it works.